before I start, you can read syllabus on your own, but this is what 49. Why you all take so long to walk? Huh? Too very long to walk, right? Or release late? Release late, Oh, sorry, recorded already. 49 release late. Sure, Yes, okay. Now, instead, let me introduce a few terms. Alright, let me introduce a few terms. A population is an entire complete set of objects. Okay, I tell you like that, you probably won't understand. Can I have attention, please? It can't be that first minute people are already closing their eyes. If you close your eyes in the first minute, guys, just don't come in. I'm serious about this. Okay? Okay, start. In the example given in your notes, we talk about the average weekly pocket money. Alright, average weekly pocket money. Now, if you are interested in the university's 10,000 undergrads, then actually with the population, oh sorry. Yeah, my bad. It was frozen. Sorry. Now, just to talk about this, let's use weekly pocket money as an example. Alright? If we are interested in the weekly pocket money of undergrads in the university, then the entire population will consist of 10,000 people. That's population. Correct? Now, in order to get a sense of how much undergrads are being given as pocket money, alright, what do? Do we sample 10,000? Is it actually possible to sample 10,000? Or rather, is it practical to sample 10,000? Probably not. So, we will usually take a sample. Now, this whole chapter, can I have attention, please? This whole chapter is about what is this distribution of this sample that we take? It's about taking a sample so that we can get a sense of how what is the statistic of the entire population. For example, if you are interested in weekly pocket money, we take a sample so that we can get a sense how much are undergrads given on a weekly basis. We can't sample 10,000. If we can sample 10,000, well and good. There's no statistic to talk about. It's an accurate data. Correct? It's actually the average weekly money, pocket money, but we can't, and we usually don't. We'll take a sample. Now, this whole chapter is about what is this distribution of this sample. You got it? Can? Let's get a quick overview. The whole purpose of taking a sample is to obtain estimates. Estimates of what? Estimates of some parameter. Now you may think, when we talk about the statistic that we are talking about is weekly pocket money. Correct? The statistic we talk about is weekly pocket money. Now, the parameter can be the mean. That means you may be interested in the mean pocket money of the entire population. That's not the only thing that we can be interested in. We may want to find out the variance, correct? Parameters can be mean, can be variance, can also be median. Correct? You all know, right? Mean may not be the only way to measure the central tendencies of statistics, but it can be median as well, the middle value. So, never mind. Let's do the brief overview. But how do we get these estimates? We will take samples. The most important thing now, we must make sure that no group is overrepresented or underrepresented. How do we do it? We usually we must ensure that we random sample. What is a random sample? A random sample essentially is one that every member has an equal chance of being selected. Let's say I want to find the average height of a VJC student. I will not go and sample the volleyball team. You know what I'm saying? I will not. I will not go to a volleyball team and then sample 3 students from there. You follow what I'm saying? If I want to find average height. I must ensure that the way that I sample is that every member has equal chance of being selected. And obviously my volleyball example is an extreme example. You follow what I'm saying? Yes? And second, the selections are independent of each other. Of course. Yes? Make sense? Alright. A bit dry. But let's start with the first example. How do we ensure a random sample? Let's just say that a maker of a drink wishes to find out the taste preferences. Give a reason why this is not a random sample. Why a sample that consists of shoppers who have just bought the drink is not a random sample. Because this drink wants to find out taste preferences of the residents. She wants to find out the taste preferences of the average resident. Now obviously, if you just sample people who have just bought the drink, they have a certain preference. So therefore, not every single person has an equal chance of being selected. So the answer is very simple. Not everyone has an equal chance. Now, next one. Why is it not a random sample? A sample consisting of every 50th shopper. Why is it not a random sample? Because it's not independent. Because I choose the first one, and every 50th shopper will be selected. So the reason is very simple. Because the subsequent selections will depend on the first selected shopper. It's not independent. This tackles the idea of independence. Okay? Right. Okay. Now, sampling of the sample mean. Now, this may sound very difficult to some of us. All right? But never mind, let's use an example to find out, to investigate this. Let us just say I have an entire population. This is the population, very big. N is large. And we take a sample of size n. No, I should not use n. Population is very big. Okay? I take a small sample of size n. Maybe n equals to 5 or something, doesn't matter. You take one sample. What do you take? Sorry. 1, 2, 3, 4, 5. Example only. Let's say n equals to 5. Right? With replacement from a population of a certain mean and a certain variance. So far so good. Suppose, okay, let's be concrete. Let's use height. Okay? I take 5 students. Pick 5 students. 1, 2, 3, 4, 5. Okay? From this entire population from the school. Okay? Now, I obviously have what I call a sample mean. Let's contrast this with the population mean. The average height of these 5 students is not the population mean, right? It will just be just a mean, sample mean. We call it sample mean. Okay? Now, I pick another 5. I obviously get another sample mean. I pick another 5. I obviously get another sample mean. This sample mean has a distribution. I repeat one more time. This sample mean has a distribution. Because every time I pick 5, I will get a different value. So far so good. Yes? So in example 2, we are going to investigate what is the distribution of a sample mean. Now I'm not going to use height. I'm just going to use a very simple discrete random variable. Let's do example 2. A box contains 2 tickets, 1, 8 and 1, 12. Very simple, just 1, 8 and 1, 12. X is the number on a randomly chosen ticket. Find the probability distribution of X and sketch this graph. Now this one first part is very simple. You think about it, alright? Either you get 8 or you get 12, probability you get half. Yes, copy when it's blue it's copy Now your friends are sleeping. As I just at this early stage, you either wake them up and ask them to carry on and soldier on and then pay attention, or you get them to leave the LT. Alright? Okay? Either you get a 8 or you get a 12. Right? Either you get 8 or 12, so you get half and half. Now, so simple, we want to find the mean and the variance. Now, this is the probability distribution. You're supposed to sketch this. It's simple. You get probability, you get an 8. You get 2 dots here. You've got to sketch the 2 dots. So far, so good. 2 dots printed for you? No, right? Now, can you then very quickly tell me what is the mean? This one is stats 1, discrete random variable. Or just quick recall. Okay? Discrete random variable, what is the mean of this distribution? You can do quick calculation, or you can just by symmetry of this. You can half here, obviously the mean is 10. Obviously, correct? The mean must be 10. And I don't think I need to go through how to find the variance. You recall, this is from stats 1. This formula is from stats 1. Expected value of x squared minus expected value of x whole thing squared. Alright. Now, what is expected value of x squared? It is x squared, which is 8 squared times half plus 12 squared times half. This whole thing is this one. Correct? Minus away your 10 squared. Correct? Recall? I'm sure you all recall this, yes? Then you get a 4. Okay, so far, so all this is just revision for stats 1. How do you calculate the mean and the variance of a discrete random variable? Okay. Now, I'm not asking for the distribution of x. X distribution is just this. Okay? Now let's take a look at the question back here again. Samples of size 4 are taken with replacement. Find the sampling distribution of the sample mean and sketch this graph. Sounds difficult. But let us begin and end in mind. What happens now is now we are saying, I take 1, I take 2, I take 3, I take 4 values at random. First time it could be 8 or 12, second time could be 8 or 12, third time could be 8 or 12, fourth time could be 8 or 12. I find this mean. Alright, what is the distribution? Okay, let's try. You see, when you take 4 different samples, it could well be all 8s, or 3 8 1 12, 2 8 2 12s, 1 8 2 3 12s, and 4 12s. This is the only 1 2 3 4 5 possible outcomes. Follow? Yes? Yes, 5 possible outcomes. What is, if I take all 8, does it make sense that the sample mean, I will definitely get an 8? Make sense? If I get 3, 8, 1, 12, you take mean, you will get a 9. Correct? What is the probability that I get all 8? Recall, probability of an 8 is half. Probability of a 12 is also half. So this one is just half times half times half times half. Correct? I'll get 1 over 60. What is the probability that I will get 3, 8, and 1, 12? Where I will get a sample mean of 9 is actually half times half times half. This is to get 3 8s. The last one is to get 12. But that's not all. You must actually multiply by 4 factorial over 3 factorial. You know why? Yes, because it could be 8, 8, 8, 12, 8, 8, 12, 8, 8, 8, 12, 8, 8, or 12, 8, 8, 8. Correct? So how do you arrange 4? You could be in any order. So actually it should be times 4. This one, how do you get 4? This is actually 4 factorial over 3 factorial. Then you get a 1/4. Yes? So similarly for 8, 8, 12, 12, can we quickly calculate now? Just revise a bit of your probability. Come, 30 seconds, write this down. How do you find 8, 8, 12, 12? Yeah? How do you get 8, 8, 12, 12? I saw a video over the weekend. It's quite funny. Later I show you. You know who is Mr. Brown? Just see. You want to see his video? It's really funny. It's really damn funny. He's the funniest guy in Singapore, I think. Okay, anyway. You get 12 times 12. That's 12. Half times half times half times half times 4 factorial over 2 factorial 2 factorial. There gets 3, 8. Why 4 factorial over 2 factorial 2 factorial? Because we have 2 repeated. Okay? You want to go through. Okay, let's come back. Let's come back. What do we want to do? We want the distribution, probability distribution of the sample mean. And the sample mean could be any of these values. Okay, the rest is calculated for you. And the probability of sample mean is 8 is 1 over 16. This one, this one, this one. So I'm going to transfer this to a simpler looking diagram here. Table, sorry. Alright, so probability you get 8 is 1 over 16. You get all these values. Just transfer. Got it? Yes? So if we present this on a probability, on a graph, there's the probability you get 8 is 1 over 16, 1/4, 3 over 8, 1/4, 1 over 16. So you get something like that. Recall, this is different from the distribution of x. This is x bar, this is x. You follow what I'm saying? This is the sampling distribution of x bar, where x bar is the average values of 4 independent observations. Got it? It is very different. If there's nothing to take away from this lecture, I need you to know this. The distribution of x bar is different from the distribution of x. We call x can only be 8 or 12, whereas x bar can be 8, 9, 10, 11. For any distribution, it's different. But you realize that the expected value of x bar, this one, just by observation, stupid. Here, 10. It's 10. It's also 10. You realize that this is also the same as expected value of x. Now this is x bar, not x. You realize that the mean is still the same, still 10. Next, I want to find the variance of x bar. Do you expect it to be the same? Let's find out. Let's find out. How do we find expected value of variance? We need this, but before that we need this. That means how? You look at the table again. You take this square times 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 this. The work is done for you. All you need to do is just to copy this one. You will get a 101. Okay? 10. Now, if we calculate 101 minus 10 square, you will get a 1. Okay, the important point is here. Look up. You realize that expected value of x bar, that means the mean of the sample mean, is the same as you will get 10. Can you have attention, please? You will get 10. However, the variance of x bar now you realize that it's 1. It's actually 1. But if you look up in your previous page, what is the variance of x? It was 4. You see, was it 4? Yes. But now your variance is 1. Actually, it is 1/4 of 4. It's actually sigma square over n. That means the n is what? N is the sample size. Remember we took 4 samples? Do you remember we took 4 samples? You realize that the variance is just the variance of the x divided by n. Just an observation. Alright? And you realize that it is true for all x. It is true for all x. Now, just a few notes. Bear with me. I think this is not new. We use x1, x2, x3, x4 to denote a random sample of size 4. That means x1, x2, x3, x4 are 4 independent observations of x. I give an example. If we talk about height of a student in VJC, I take one randomly, assembly, I say, oh, I close my eyes and then pick point, okay, randomly 1%, another percent, so 4 independent observations. Now, Does it make sense that all the x1, x2, x3, x4 will have the same distribution? Same distribution. And x bar is the mean of the random sample. In this case, in example 2, I have 4, n equals to 4. N equals to 4. I pick 4 and 5. Never mind. I hope you understand example 2, and the most important thing I want all of us to know is this. The sampling distribution of x bar is different from the distribution of x. Totally different. Alright? Can? Okay, we'll take a mini break.